I welcome you all for SOHA weekly academic lecture series on Kubernetes dive into future of infrastructure. It's my immense pleasure to introduce the speaker, Mr. Sanmay Prakash Mishra. Mr. Mishra has 12 plus years of experience in design, development of large enterprise application software using Java-based technology in various domains like finance, health, and hospitality. He is expertised in re-engineering legacy application into container-based cloud applications. He is Amazon Web Service Certified Solution Architect, now currently working as a principal software engineer at world's third largest asset management company, Fidelity Investment Bangalore. So I request our speaker, Mr. Sanmay Prakash Mishra, to continue. Sir, please.
Yeah, thank you, ma'am, for the introduction. Let me share my screen. So Kubernetes is basically the future of infrastructure. It's a vast topic. Today, I would like to give you an introduction to all of you on Kubernetes. In next couple of years, when all of you will be working in some software company, either most of the applications are either containerized based applications, or they will be on their way to become a container based application. So basically this behind the scene you are seeing this steering, right? So this is basically the logo of the Kubernetes. So let me start with a layman's term, like what is Kubernetes history. So the name Kubernetes is originated from Greek. It's meaning helpsman or a pilot, or it's basically the word of it's the root word of governor. Sometimes it's also called as K8S. It's because exactly there are 8 letters in between K and S. It's basically there is a concept in computer science called numeronym. It's mostly because computer science people are very lazy, and like instead of pronouncing the full name, they usually find out many shortcuts. So K8S, many of the literature you will not find it as Kubernetes. You will find it as K8S. That similarly, there's a numeronym of internationalization. It's called I18N, because there is exactly 18 letter between I and N. So as you guys be working in the software industry, you'll see a lot of such terms. And Kubernetes was originally developed and designed by engineers at Google. Google internally uses something called Borg. Later they changed that to Omega, basically to manage and deploy their container. All of you must have used Google Map and many of the Google services. So many of their services offered by Google currently runs on containers. As and when we move down to the slides, this concept of container will get clear. But this is just a basic history of what Kubernetes is. And like basically it was originally developed by Google, and at some point of time Google decides why only this is a great tool, why only we need to use it, should be open to the entire world. So they donated this Kubernetes project to a newly formed organization called Cloud Native Computation Foundation, CNCF. So they are basically currently managing the Kubernetes, all the upgrades they manage. They also research on various container-based technologies. That's basically those are various tools which assist the Kubernetes. So what exactly is Kubernetes? So Kubernetes is an open source container management tool which automate container deployment, container scaling, and load balancing. So this container management, container, you think for the time being, think container is nothing but an advanced version of virtual machine. It's just a virtual machine which using which we can run our application, and Kubernetes is helping us in managing those containers. And using Kubernetes, those container can be it's very easy to deploy and easy to scale and easy to load balance. Usually the scaling and load balancing goes hand in hand. I would like to give a very beautiful example of how scaling and load balancing is making our life easier. recently Hotstar published a report in India Pakistan match, when India is playing well, like a lot of people wanted to see the match, and all of a sudden there is a high traffic to their Hotstar application. But as and when people realize India is not playing well, and India team is getting out, the load generally get reduces. So their application is able to handle this capacity increase. Like when a lot of users are getting added, automatically their application is getting scaled. And when number of users are reducing, automatically it's scaling out. So it's automatically they have that elasticity. It's based upon load, it can increase, and based upon if there is no demand, it can decrease actually. So it schedules, runs, and manages isolated containers, which are runs on physical, virtual, and cloud machines. So if you have the Kubernetes, you can install it in your machine. It can be a physical, it can be a virtual, and also it can be any cloud machine. Currently all cloud service providers, be it Amazon AWS, or be it Google Cloud or Microsoft Azure, they all support Kubernetes. Kubernetes was originally written in Go programming language. This language was also initially developed by Google, and later they decided that whatever the Kubernetes infrastructure they are writing, they will be writing that in Go programming language. So today we will be talking about these terminologies, what is container, what is kubelet, what is cloud native app. So cloud native app is basically whatever software you have designed a software in such a way that it will scale, it will work in cloud. And we'll be talking about Docker, what is a pod, what is a virtual machine, what is kubectl, and what is orchestration tool. So these are some of the terminologies that will be working, and if you guys in the future work in Kubernetes, you'll be hearing these terms heavily. So basically, what is a container? So container is but nothing but a clean way of running the application in isolation. They provide a solution to a problem of how to get software to run reliably when you are moving from one computation environment to other. So when you run a Docker image, Docker basically we'll talk about the Docker also. So Docker, just think it as Docker is basically an engine. Using that engine, or basically it's a software, using that software we can create container. So for the Docker, basically what we first need to create is a Docker file. That is basically a text file where you'll be defining a couple of attribute what you need. Like I need a Tomcat, I need Java 8 or Java 9 or Java 11, and based upon that you create your image. And on the runtime, when you run that image, that's becoming called as a container. And some of the major benefit of container when you're running your application in container is it become a OS independent. It doesn't matter you run it in Ubuntu, you run it in Red Hat, you run it in Windows Server, anywhere you run, it doesn't matter as long as you have the container engine is installed in that system. And with container also, it's very easy to package and distribute the app easier. With Docker, there is something called, they have something called Docker Hub. So what usually they do is that once you create your Docker image, you put upload that to Docker registry. So once it's in the Docker registry, you just send it to anyone with the credential. They can download and they can run the application very easily. It's easy to distribute. That's one of the benefit. Another thing is that if you're writing a code, it's very portable across environment. You run it anywhere. Like basically what Java, you must have knowledge on Java. So Java is very famous because you compile it once and run it anywhere. You compile it in Windows machine, you compile it in Linux machine, but when you run, as long as the JDK or JVM is there, you can run it any place. So whatever Java did to the programming language, Docker basically, or this container, they did the same thing to the application. So once you create the image, no matter which operating system you are using, as long as it has the container engine, you can very easily run it. And no matter whether it's Linux, whether it is Ubuntu, or whether it is Windows, it doesn't matter to you. So that is a very big advantage, because earlier days what used to happen is that people will develop an application in their local system. When they give it to some other team, when the other team tries to run, it will fail, because there are a lot of binary files which while developing they have installed, that is not there when in other teams, when they try to run it, it is missing, and that's why they will get a lot of errors. And it's create a lot of problem for everybody to solve, and it's a wastage of time. But with a Docker, what happened? You just create the, as I mentioned, we need to create an image. So you just create the image, and you share the image, and that image has all the binaries that is required to run the application. So you just provide that image, and whoever has a runtime engine installed in their machine, they can just need to create the container, and they can start using the software. That's very because of this region, it's containers are very widely adapted across the software industry. And another benefit is deployment of the application will be very easy. Let's say you have found some bug while application is running in the production. You found some bug, you made some fixes. Deployment is also very easy. You just regenerate after the fix. You just regenerate the image and simply deploy that image. There are pipelines available. Using that pipeline, you just trigger. It has various stages. It can run automated test suite on that pipeline, and it will build every image, and it will directly push everything to the production. It's very easy to deploy. So that's another benefit. And also, using containers, it's easy to scale at the production. As I have given an example of the Hotstar. So on the production, they have all those things set up correctly. Like today, like be it Amazon or Netflix or Hotstar, they all use this container technology heavily, and it's very easy to scale. And it's basically a time tested solution, which is widely adopted. Now in this I'm trying to explain like what is difference between a virtual machine and container. So I mean 10-15 years back, like everybody used to design a virtual machine. So what happens is you want to let's say run a software, develop a software you want to run. So what will happen, either you will build your own infrastructure, or you will rent a server. So what they do is that basically there is an infrastructure. You have a big computer in server infrastructure. On top of that, there will be an host operating system. Usually this host operating system is either Linux or Red Hat Enterprise, or it can be Windows Server as well. So on the top of host OS, we have installed a software called Hypervisor. Hypervisor is nothing but a emulator. Like some of the example of hypervisor as VMware or maybe Oracle Box, VirtualBox. So those are basically hypervisor. They are just emulator. So once you install the hypervisor, on top of hypervisor, again you can install a complete operating system. So you can install this yellow thing. It can be a Windows Server again. It can this green guest OS can be a Red Hat Linux, and this can be a Ubuntu. So three operating system. If this infrastructure has enough capacity, then definitely you can install three independent OS. And if any company owns this entire infrastructure, there are different teams will be there. Let's say there is a billing team, there is a HR team, and let's say there is a particular inventory management staff. They have a software. So every software they can deploy in each of this application, and they own this particular guest OS stack. But here the problem is, like once you have a hypervisor, when you are installing, let's say this yellow thing is a Windows server. When you are installing a Windows OS, let's say this total host OS has a total 16 GB RAM. Let's say usually it's more, but let's assume for a simpler calculation it's 16. So when you're installing the guest OS, uh, this can take, let's say, 6 GB. When you are installing a guest OS, it can take a 6 GB. Similarly, let's say you install another OS which took another 6 GB, and the third, when you are installing, it can take maximum 4 GB. So what will happen is, let's say this virtual machine 3, which we have allocated 4 GB, tomorrow a lot of this is a very famous application, and a lot of users or lot of traffic one day it came to this particular machine. So what will happen, it might need more than 4 GB. And during that time, let's say this green box or this yellow box, they don't have much traffic. But since already memory is allocated to them, they cannot relinquish those memory. 6 GB is allocated to that. Even if there is no traffic, they are not they are sitting idle, or they might not be using the full 6 GB. Still they will be holding on to this 6 GB memory. And similarly, this guy is also will be holding that 6 GB. But the host OS has capacity to better serve the users of this particular application stack. So that is where Docker came into picture. The key here is the efficient resource management here, because you guys, the example I gave, right, it's a wastage of resource. Even if memory is there, everything is there, still my application is not able to use. But with a Docker, how infrastructure works is you have the same plain infrastructure. Then here you'll be installing the host OS. On the top of host OS, basically you'll be installing the Docker engine. So Docker engine is just think it of like a software. It's just a software you install, and once you install, it will be just running as a process in this host OS. So if the host OS has 16 GB RAM, so this Docker engine will be use it can use all those 16 GB. Like definitely host OS will reserve something, so whatever left, Docker engine can use it. So similarly, from the Docker engine, you'll be creating a container. Like basically, this Docker engine sometimes is also called Docker daemon. It's basically, as in the earlier slide I mentioned, Docker image is basically once you build the application, it will be a Docker image, and the Docker image needs to run in a Docker engine or the Docker runtime environment. So that this is that runtime environment, and once you run that image on the runtime, it's called as a container. And that image has its own binary libs, and it has own the required application. You want to install JDK8, you want to install Tomcat, you want to let's say for your Node.js application or AngularJS application, you wanted to install Nginx server. So everything can be installed in the Docker image, and you just put it here. And here the resource management is the key, which is very efficiently it can use. So for example, tomorrow, let's say this guy needs 8 GB of RAM, but these two people are not heavily loaded. So definitely Docker host has 16 GB of RAM. They can use this memory. They can this Docker engine can allocate more memory to this particular container. So this is the very good use case of Docker container. Why it's basically adopted widely by the software community. I'd like to take a pause here. If anybody has any question on this particular what is Docker engine here.
Anyone have any question? You can also put in the chat box.
Okay, sure. We can maybe take the question at the end also. Okay, let me proceed then. So what is a Docker? So Docker is basically, you can think it of as a tool that help you create, deploy, and run your application or projects by using the container. Usually, when you somebody ask what is Docker, it's basically a company name. So for example, when I ask what is Google, so Google is basically a company name, but nowadays it's a synonym to a search engine. When we say Google when we say Google, everybody understands it's the search engine. So similarly, Docker is it's a company name, but when I say Docker, it's basically a company which provides
One have
a
a question. Just a
yeah.
minute. One have a question.
Hmm.
I is asking, can Docker use the hardware like GPU directly?
Yeah, it can use, but it depends upon I mean, Docker engine is basically this container can use actually I mean, this container, let's say I have deployed any application which is using the GPU heavily, so through the Docker runtime environment it will be using all those things. Let's say I have a graphics intensive application that can use.
Okay, thank you.
So what is Docker? As I'm explaining, it was just a name of a company, but just like Google is synonym to search engine, this is just a become a synonym to Docker runtime engine, or it's just a software using which we can run our softwares, or run containerize our softwares, and we can run. And Docker is like one of the. There are many tools, container tool like Rocket, which is a competitor to Docker, but Docker is currently the market leader, and he's driving the containerized movement. Now, how exactly Docker we use? So basically, in the Docker, there is three part mainly. One is called Docker file. So Docker file, you need to provide couple of things. Like this is a very simple form of Docker file which I mentioned. It's just mentioned that Nginx. Nginx is nothing but a HTTP server or HTTP web server. So from Nginx, it is trying to just copy this HTML directory. So in this Docker file, if I run this Docker particular file, I'll get a Nginx install in my image. Now, so for writing a Docker, writing a container, what I need to do is that first I need to have a Docker file. Then from the Docker file, I need to create a Docker image. And how will I create a Docker image is by providing this command. There is something called Docker build -t. T is basically the tag. I'm giving static website, so static hyphen web. So as this is my static website, so as soon as we give this command, Docker will be creating a image. Now, once the Docker image is created, this image can be run anywhere. And how will I run? As long as I have the Docker engine installed in any of the operating system, we can simply execute this command docker -p 8080 port and 80 port, and the name of like any name I can give to my application, and static web. That's the tag that I have created here. It will run that image, and it will be a new container will be created. So this is about the Docker. And like another thing is, what is image versus container? So as I have explained, like when you have the Docker file, from the Docker file you are creating a Docker image, and from the image, when you are running, a container is created, and the application inside that image is when it basically runs, we have that runtime environment. We are basically referring to that as a container. So image versus container. So an image is an application you like to run. It's the basic of a Docker container. A container is a running state of an image, basically. So if you think image is just a class, container is just an object of that particular class. Now, how will you run containers? There are various way of running. Either you can run it as a Docker solo. So using Docker solo, the command I have shown you, right? It's just a Docker. In the previous slide, the command I have given you, the Docker run. So using this command, we can run the Docker. So this is basically called solo, Docker solo. Like basically, I'm just running one instance of the container. And here it's a command line based interface. Using that, we can run the container. Using this, we can like basically, as long as you have the Docker engine, you can run it anywhere, any operating system. But the problem is, when you are running the Docker independently, you have to manage your network and storage configuration, and you also have to take care of your scaling part. So that is if you are using Docker, if you are running the container in solo mode. So people face a lot of problem in managing this network storage configurations, and taking care of all this scaling related stuffs. So people come up with better intelligent tools, which is called container orchestration tools. So when you're doing a when you're using a container orchestration tool, it's basically a tool which will using which you can it will give you a cluster using which you can run manage containers. If one container goes down, automatically it will recreate a container. Managing scaling and availability of the container, everything will be automated, and it will be managed by the orchestrator, which is the Kubernetes. A lot of tools available with Kubernetes also, as it's a open source software. There are a lot of contributor. You will find a lot of tools are available, and it's very widely used by the community. These are some of the popular container orchestration platform like Kubernetes or Docker Swarm or Mesos or Rancher or Nomad. But Kubernetes is very widely used in many, as they have proved themselves to be very efficient, and it's open source, so you don't have to pay any money to use it. And definitely, it's backed by Google. It was developed by developers from Google, and it's a very efficient tool. So this container orchestration, let's look at some of the advantages. Helps us running complex applications with multiple containers at scale. Some of the capabilities include scheduling of the pods. It will automatically schedule all your application as and when required. So with Kubernetes, what happens is that you have to define everything in a file. Like they call it as a desired state. Let's say I'll say like I need three instances of my application. It should be always up, it should be load balance, everything I will be writing in a file. I'll be giving it to Kubernetes, and Kubernetes always makes sure that whatever desired state I have mentioned in the file, on the real state of the application is also the same. So the Kubernetes cluster will keep doing all those things for me. It will make the life of developer and all the management team of the application it will make their life very easy in automating all those stuffs. And also you don't have to worry about the networking. Kubernetes when I'm running multiple containers, I don't have to worry about the networking, assigning IP address, assigning ports, opening firewalls. Nothing is required, everything will be taken care by Kubernetes. And as I mentioned, it's when you are using Kubernetes, it's very from resource management point of view, it's very easy. It's very efficient, and basically it saves a lot of cost. Now this is basically the Kubernetes architecture. A couple of things you guys need to remember here. So this control plane is basically the master node. Kubernetes basically follows a master slave architecture. So this is the control plane, which is the master node of the Kubernetes. In this diagram, although I have shown one master, but Kubernetes cluster can be run with multi-master mode as well. So there you'll be having multiple masters managing multiple worker nodes. But just for simpler understanding, let's say we have a very simple cluster which with having one master and there are two nodes. So to the master, how will you access from the outside? This Kubernetes, the cluster can be accessed from the outside. Kubernetes is providing an UI to manage all those components. And there is another command line tool as well. It's called kube control. Sometimes people pronounce it as kubectl. So this kube control command can be used from if you install that in your Windows machine. It's just a kubectl type, and using that you can remotely interact with the Kubernetes cluster. So this is the master node. Master node has mainly four important component. One is the API server. API server is basically responsible for interacting. Basically, it's the gatekeeper. All the outside requests, like maybe through user interface or maybe through kubectl command, it will first come to API server. Now API server, yeah, based upon the resource, based upon the request, let's say in the kubectl command we have provided to create pods. I'll come to that. What is a pod? So let's say we provide a command to create pod. So what will happen? Scheduler will be responsible for creating those pod. It will give the instruction to the worker node to create the pods. Now there is third important component of the master node, which is called controller manager. So controller manager is nothing but it's just make sure the desired state and the actual state of the Kubernetes is always maintained. So for example, I have defined in my application that always three instances of my application should be running. So it will make sure I have three applications running for me for my particular application. Now, fourth important part of Kubernetes is called etcd. So etcd is nothing but a key value pair distributed database. It's a database. This is originally it was not developed by Kubernetes. It was developed by a different company, but it's a very widely used key value pair distributed database. And this database they use to maintain the state of all these worker nodes. So this is all the important component of the master nodes. Now let's go to worker node. So one master node can be managing n number of worker nodes. In this screenshot, I have just shown two. So worker node, what are the main component? One important concept is called pod. Pod is nothing but a basic schedulable unit in Kubernetes. So like everybody will be asking you how many pods your application has, how many like what you have deploying in the pod. So pod is the basic scheduling unit, like of the Kubernetes infrastructure. Now pod, like earlier we have discussed about container, right? So pod is nothing, it's just a wrapper around the containers. Like one pod can contain more than one containers. In this example, like pod 1 contains 3 container, pod 2 contains 1 container, pod 3 is containing 2 container. So this pod is a very critical component in worker node. It is always best practices to not more than 2 container in a pod, because when you are having more container in a particular pod, it's very, they are tightly coupled. Like if anything happens to this pod, this entire three application will goes down. But if I distributed across multiple pod, then there is a very less probability that all three will crash at the same time. So being said, that pod is one of the important component of this worker node. Another important component is the Docker engine or the Docker runtime environment. This is what we discussed in the earlier slide. This is because of this Docker engine, this container will be able to run. Uh, Another important component is kubelet. So kubelet is nothing but a agent. It acts as an agent. So how this worker node and how this master node communicate with each other is because of this kubelet. So kubelet is basically act as a agent. And there is some confusion, like after every few seconds this kubelet will be sending a heartbeat to the master node, so that the master node can store it in this HCD database, that okay, this worker node is up and running, there's no health issue. And similarly, like another important component is called proxy. So proxy is nothing but the networking part of this worker node. It's take care of all the IP address assignment. Everything is managed by this proxy. And proxy is also helps in managing when, let's say, your pod one here wanted to communicate with pod one here. So this proxy, because of the networking provided by this proxy, they will be able to communicate with each other. And another important point here to remember is that when IP address is assigned, it's not assigned to a container. IP address is always assigned to a pod. Okay, so this is all about the Kubernetes architecture. So introduction to pod. So pod, as I mentioned, this is the smallest schedulable unit in the Kubernetes cluster. It can contain many containers, and containers within a pod usually shares the IP address space, port space, storage. They all belong to the they all can use the same storage allocated to that particular pod. And container within a pod can communicate with each other via mechanisms IPC mechanisms such as semaphores or shared memory. Now, what is the life cycle of a pod? So when the pod is initially let's say from kubectl command, I requested to create the pod. The pod is in pending phase until the container has started. So that is the pending state. Then one pod can have multiple containers. If one container is running, then the running start it will be in running status. Now if job of this pod is complete, and in case of a proper termination, this will be in succeed state. And if there is any failure, it will be in failed state. And there is another state which is known as unknown. In the previous slide we have seen something called kubelet. So kubelet, I said, it's just the agent. So let's say for some reason kubelet is not able to communicate the data to the master node that this node is up. So master node will think this is in unknown state, and it might kill this pod, or and it will create another pod in some different node, so that there is no interruption to the service provided by the application. Now this is basically when we define the pod, there are a couple of things. Basically, how will you define a pod, right? So in Kubernetes, everything is called declarative configuration. So declarative configuration in the sense, whatever you need, you just need to write down in a YML file. It can be JSON also, but widely people follow YML because a lot of tools are provided and it's easy to read. So this is a typical example of YML where I'm creating a pod. So you can see this API version, this Kubernetes version 1, and its kind is pod. And I'm defining a couple of metadata, like its name is called Magalix agent. So Magalix agent is it's a plugin which is available for Kubernetes to efficiently manage the application usage of its memory and CPU. So if you use Magalix agent with your Kubernetes, if it's just a plug and play. Once you define this in your file, your billing is amount is going to be reduced. It helps in better management of the memory for the application. So here in the structure we have define a container, and this is how we define. This is the containers. The name is database. This is the image which I'm installing MongoDB, and there is something called resource. The resource, I have request memory of 300 megabyte and CPU of 500 millicore, and I have also defined a memory of 500 megabyte and CPU is 100 millicore. 100 millicore is one core CPU core. So we'll talk about next slide. What is about this request, this memory limits and all. Just like I have defined here two containers. This is one container, and this is my second container where I'm running Magalix agent. And for this Magalix agent, I'm allocating 300 megabyte, 250 millicore, and again I am providing a limit of 500 megabyte and CPU core of 1000 M. So now let's understand the resource limit that is used in Kubernetes. So request are nothing but that is what container is guaranteed to give you. Like basically when I run my application, if I define a memory of 32 megabyte, so I'm guaranteed to get 32 megabyte. So basically what happened, Kubernetes cluster, when through kubectl or any other tool I deploy the application, Kubernetes will find a node for me where definitely I'm going to get a 32 MB of minimum for my container one. And the CPU I have given a 200 millicore. And limit on the other hand, it's basically like if by because of some reason my application try to use more than this limit, then Kubernetes will kill this software, because I don't want to jam. There are instance of DDoS attacks, right? Distributed denial of service. So like people will bombard your application with with lot of requests, so that even normal people won't be able to access your application. So in that case, if there is any a lot of requests coming, your application, you are not expecting a lot of load, but all of a sudden a lot of requests is coming and a lot of memory spike is coming. So for this container, Kubernetes will kill it. So your other containers running in that application won't get impacted. So because for that we can define limits. And similarly we have memory, the memory usually here defined as megabytes. So 1 megabyte is 1.04 megabyte. So megabyte is just a there are two way of representing the data storage, either in decimal or binary. So this is the binary, we call it megabyte. And similarly, CPU is usually configured in millicore. Millicore is nothing but a metric of measurement, which is used to measure the CPU usage. So, for example, usually one CPU core is 1000 millicore. So here, for example, when I say 200M, it's basically 200 millicore. That means I'm configuring it to use minimum of 20% of CPU, and maximum here I have given 250M. So maximum it can use 25% of the CPU. Beyond, if this container tries to use beyond 25% of the CPU, Kubernetes infrastructure will throttle this application, and it's basically safely it will terminate this. And similarly in my second container, I have given a limit of 750M. That means 75% of the CPU it can use. Now another just that is the earlier YML file that we see, that is to define a pod, and this is another YML file where we can define the deployment. And here the important factor to look at is the replicas. Replicas as three. So I have defined three replicas. That means what happen is that when I deploy this application, Kubernetes infrastructure will always try to run three pods for me. If I'm running I deployed my application, Kubernetes will create three pods. It can be on the same node if the space is available, same worker node, or it can be in a different worker nodes. So it might allocate the pod in multiple worker nodes, but one pod at a time will be allocated to only one worker node. So I have given three. That means Kubernetes manager is always going to make sure that all the time I should have at least three containers of my application is running, of my pod is running. And similarly, there are some other metadata I am defining, like this is my app label. These labels are very helpful. They help you, they provide a UI. Using this label, you can search your application, you can track down many information, track down many information, like what is the memory issues in the runtime production environment. Basically what will happen, it will give you a lot of diagnostic information, and it can be searched by these levels. So this is a sample YML configuration, and that's all about the deployment. Now, another important tool I would like to mention is the kubectl. So kubectl, we have used that term a lot of time in my previous slide. So kubectl is nothing but a CLI tool, and it basically act as a remote control to my Kubernetes cluster. So using that, I can remotely manage my Kubernetes application. So in the right side, you can see that kubectl apply deployment. So using this command, we are applying the deployment. The deployment file I just on in the previous, that will be saved as a deployment.yml. Then I'll execute this command kubectl apply -f, and deployment will be created. Similarly, to see the view the deployments that current cluster has, we can use kubectl get deployments. So using this deployment, it shows me all the information, like what is the name I have provided. It's giving ready one by one. So this is basically how many containers I have. In this case, I have just one container, and it's up to dated and no update is required. Available one, and age it shows 22 seconds. So similarly, there is kubectl get pods. It will show me how what are all the pods running. So this is also the name. This is in ready state, and this is in running status. It has not yet restart. This container is running all good, and here also it shows the age. And this kubectl is really very useful command, using which we can even log into those remote worker nodes. We can see the logs. If you need to diagnose any production issue or something, there are many tools available, but this is one of the way we can log in and see all those logs, and we can also scale all those application manually if required. Now, another concept that Kubernetes has is namespace. So namespace is nothing. It's basically a better way to organize the cluster. So let's say I have many departments in my company. So each department I'll allocate one namespace. So all of their application will stay there. All. For example, I have a HR department. All the application related to HR department, let's say, have a namespace. So it give me a better isolation. So using that namespace, I know that this namespace is always used by my HR team, and accordingly, it's basically a logical separation, which is easy my life to allocate resources. And it also helps me in achieving multi-tenancy. So multi-tenancy is like, for example, let's say there's a company which is who is selling their Kubernetes as a service. So what they will have they will have is, each customer, they will give a separate namespace, so that customer will be bounded to that namespace. They cannot access anything beyond that namespace. So it helps achieving multi-tenancy. And namespace, like basically the following is kubectl command I have shown. This command can be used to set the current context or current context of a namespace. If you want to change the namespace, let's say you have access to multiple namespace for your company, then you can use this kubectl command. Config set minus context current namespace is the new namespace you provide. Your namespace will get changed, and namespace mainly helps us in managing. Like in one place, I can manage. I can set the limit and resources for the entire set of application. That give me an edge. So this is just a recap of the Kubernetes architecture that we have seen. So just to just remember this thing, this is very important. This is my master node and this is my worker node. How my master node has mainly four component: scheduler, API server, HCD database, and controller manager. So all this kubectl and UI, this tool generates various API. These APIs are they call a particular API, and that API will be, all those API requests will be coming to API server. So API server is nothing but act as a gatekeeper. So based upon the request, they will do based upon the request they will be doing the desired changes. So let's say I requested to create a pod, so API server will receive that request. They will ask the scheduler to create that pod. Now, once scheduler place that request, it will be updated in HCD and database. Then controller manager will see it that that's the desired state, and it will try to achieve the actual state by doing the needful steps. So this is the master component. And coming to the worker node, we have important component is kubelet. Kubelet is basically the act as a agent. Using this agent, worker node can communicate with the master node. This usually sends a heartbeat kind of thing. So based upon that heartbeat, this API server, basically heartbeat, when I say heartbeat, is basically means it's a API. They send 200 OK response. That means it's all good, it's up and running. So API server will receive that particular request, and he register its HCD database that this worker node is working fine. Another important component of this worker node is kubeproxy. So kubeproxy is basically involved in networking. It's involved in networking, assigning IP addresses. It manages all the network or communication within the worker node, master node. It manages. And similarly, then we have the Docker engine. Obviously, that's the important. But Kubernetes doesn't only depend upon Docker. It's basically the container engine. It can be Rocket also, but Docker is just a widely adopted so far in the industry. Now inside the Docker engine, we have something called pod. This round what are the round thing that you're seeing, this is the pod. And inside the pod, I can have one or more containers. So these squares that you're seeing, these are the containers. So this is how the worker node and master node interact with each other. This is all about the Kubernetes architecture. So that's all I want to talk about today. If there is any questions, we can discuss about that. And this is also in my email address. If you guys still find any questions, just drop me an email. We can talk, or we can meet to discuss all about this.
Thank you, sir. It was a wonderful talk. I heard about Kubernetes, and I just want to ask a simple question, sir. I'm having a doubt that how do we control the resource usage in the pod?
I have shown you those pods, right? Those YML configurations, memory limit in one of my slide. Maybe I can share that again. So here basically when you define a pod, you can give your resources. So when you're defining the request, you're defining a memory and CPU. So when you're defining 300 megabyte, Kubernetes is guaranteed to give this pod this much of memory, but you are also setting a limit. You are setting a limit based upon your requirement. Like if limit goes beyond this, Kubernetes will terminate this load. You can adjust as per your workload. You can adjust this memory configurations.
Thank you so much.
Anyone want to ask any question? Sir, there is a question
Mhm.
in the chat box. Is there any special training needed to operate with KTS?
Yeah, there are a lot of training in the sense, internet. You will get a lot of tutorials. Also, training. I think there are many online training available to how to manage, and also you can get certified on Kubernetes certified cluster administrator or developer like that. Certifications are also available. That can be done.
Thank you, sir. Bharat, sir.
Yep. Hello. Good afternoon.
Sir, sir, I request you to just give give the vote of thanks.
Okay. Uh, Good afternoon, everyone. Um, on behalf of the Computer Science Department of Shiksha Anusandhan University, I express our deepest thanks to Mr. Sanamaya Prakash Mishra for delivering such a detailed seminar. From the beginning to the end, you have sir maintained the same energy and this each and every line you have explained in an enthusiastic way. So I found personally this webinar is very energetic and very detailed. So I hope it will help our students in better way. And also I want to thank Mrs. Olukalinda Tripathi ma'am for coordinating this webinar. And on behalf of the department, I also want to thank Dr. Sarda Prasannapati, Dr. Divya Sundar Das, and Mrs. Madhuri Rao for organizing this webinar. And last but not the least, I thanks everyone for being patient and listening this webinar. And lastly, I again thank you, Sanmay sir, for delivering such a nice topic. And we hope to see you again or collaborate in on some other way. And thank you for giving your precious weekend time, sir. Thank you.
Thank you also.
Thank you all again. So we can